to the Department of Communications 2019 Thomas Scheidel Lecture. For those who may be unfamiliar with this particular series, the Scheidel Lecture was inaugurated in 1998 and has brought many prominent communication scholars to the University of Washington to engage with our intellectual community. The lecture series honors the contributions of Thomas Scheidel, a member and chair of the former Speech Communication Department. And as records tell us, Dr. Scheidel was strongly committed to teaching and research. He worked with Dr. Jody Nyquist, also a faculty member in speech communication, to organize a conference of second-level language arts teachers in the state of Washington. And with Dr. Jerry Phillipson, Dr. Scheidel organized a summer institute in communication theory. This lecture series recognizes all those efforts years ago, and I'm very happy to introduce today the 2019 Thomas Scheidel lecturer, Dr. Dietram Scheufele of the University of Wisconsin-Madison, where he holds the John E. Ross Professor in Science Communication and is a Vilas Distinguished Achievement Professor. At Wisconsin, he's also affiliated with the Morgridge Institute for Research, I guess I'm just reading everything that's already behind me, which bills itself as a, quote, here's my independent research, independent biomedical institute exploring uncharted scientific territory to discover tomorrow's cures. Professor Scheufele's research focuses on public attitudes and policy dynamics surrounding emerging science. He's one of the leading experts on science communication, political communication, and science and technology policy. His work has appeared in all of our top journals, and some of this work has been supported by the National Science Foundation, the US Department of Agriculture, and the Department of Energy. His most recent research examines the role of social media and other emerging modes of communication in democratic decision-making. Our guest today is a member of the German National Academy of Sciences and Engineering and an elected fellow of the American Association for the Advancement of Science, the International Communication Association, and the Wisconsin Academy of Sciences, Arts, and Letters. He currently co-chairs the National Academy of Sciences, Engineering, and Medicine's Standing Committee on Advanced Science Communication Research and Practice, and serves on a number of its other committees. So I suspect service is not a problem for you in your end-of-the-year reviews. Dr. Scheufele's work has taken him around the academic world. After getting his degree at Wisconsin, he taught and was tenured at Cornell and has had fellowships or visiting appointments at Harvard, Penn, Dresden, and Munich. Today he joins us for the Scheidel Lecture of 2019 entitled Communication and the Future of Science. So please join me in welcoming Dr. Dietram Scheufele.
Well, thank you most importantly for having me. It's always good to be back here. I was certain that I had brought carefully distressed jeans that would just be right for the occasion. Until this morning I realized that they're all full with a full-fledged hole now, so that's the, my apologies for that. That was unintentional, but that's all I have in my suitcase. So what I want to tell you a little bit about is a lot of the work that we've been doing, and when I say we, I mean a team of students and faculty at the University of Wisconsin surrounding what I think the future of science, and I'm construing science very broadly here, is for the US and the role that communication in particular has played and sometimes hasn't. And I'll end with the idea of what it and maybe should play. But before I start, I want to give you a little bit of my background because it's been somewhat of an intellectual journey, and some of the grad students and I talked about this over lunch today. I started my career a long time ago in Germany with both my undergrad and part of my master's with Elizabeth Niller-Neumann, who those of you in communication will know as the creator of the model of the spiral of silence, one of our big kind of macro models of explaining opinion formation and establishment of social norms, who also happened to have been the pollster who did polling for every single conservative chancellor in Germany since Adenauer. And so I came originally out of the area of public opinion research and polling. Eventually went to Wisconsin and ended up spending what I thought were 2 semesters and what since then have been 20-some years, 6 years, in the US, starting to work on electoral politics and how we all make choices. I'll come back to this a little bit, about politics very often knowing very little about issues and or candidates. And this brought me, of course, then to science, which is not that different. This is actually the Wisconsin campus in the mid-19th century. And the reason I put this up there is A, because this is my office building right up there. Doesn't look like this anymore. At the time, it was teaching cheesemakers how to make cheese, literally in Wisconsin. It doesn't get any more Wisconsin than that. Now it's science communication. And there's probably a deeper lesson in there somewhere. But the reason I mention this is because I think we forget, and in this state, it's Washington State, but the big land grants have, from the day of their creation on the height of the Civil War, have had written into their charter the idea that we don't just do science, but we actually translate that science and take it to applications in society. That's what the idea of land grants was in the first place. This is why a lot of the old land grants like Wisconsin, like Cornell, still have communication programs that are in colleges of agriculture and life sciences. So it's not an historical artifact, that's just an oversight. It was actually built into the design. And so a lot of the work that I started doing at Cornell and have been doing since then in communication units in colleges of ag and life sciences has been dealing with the idea of how do we take highly complex, fast-moving science and how do we meaningfully debate it and discuss it in societal settings. So I want to talk about 4 things that I'll go through. One is why I think this is more urgent than it has been for a long time, why we may be dealing with a new type of science, and why scientists, and I mean by scientists both social and bench scientists, or even beyond the bench sciences, biological, physical sciences, and engineering, have such a hard time talking about it. Why some of that is due to human nature and a lot of the things that we hear about how we engage in motivated reasoning. Why some of our current challenges of changing media environments, and I don't mean changed, I mean changing media environments, may not help. And then I'll end with a few inward-facing lessons for what I think we as a discipline haven't always done as well as we could have in contributing to this. So let me start with why I think we are in a new era and for science. And it's new in 2 ways. Number one is I think we're actually getting and have been getting better at assessing most technical risks surrounding science. We have lots of discussions about plastics and microplastics and how we never did the life cycle assessment. Same thing for asbestos and everything else. When nanotechnology came along, when CRISPR came along, so these new technologies of either modifications at the nanoscale and at the molecular level, or CRISPR, these new gene editing techniques that allow us to make more effective and cheaper and ultimately safer modifications to the genome, we actually have started to think from the beginning about life cycle and about the technical risks. So we've really improved in that respect. What we haven't gotten better at is the idea that all of these new technologies are partly scientific problems, but to a large degree for us as a society, they're really political, ethical, regulatory problems. So some of these issues, and AI is a good example, artificial intelligence, or as DeepMind, the Google arm calls it, artificial general intelligence, have emerged in our society with absolutely no time for public debate. Most major metro police departments already engage in preemptive policing, meaning they use location data from people's phones, social media data, social network data. This is just one example from the LAPD, Palantir. Chicago does the same thing, as do others, to basically predict who is likely to commit a crime. You haven't committed a crime, but people in your networks have, and you're likely, as a result, based on all the data that I have on you, to commit a crime as well. As a result, you're much more likely to get pulled over by the police and to be basically engaging with law enforcement in some way, shape, or form to prevent that. And we can already see where the constitutional problems with that are, but we can also all realize that most people in this country don't even realize that this is going on and has been going on for a long time before most of us even understood what AI was really all about. This is a chimeric embryo that's being researched at the Salk Institute. So this is a pig embryo that's being injected with human stem cells, certain genetic markers being turned off so that a pig organ doesn't grow, but instead a human organ grows. So this is using pigs ideally at some point as vehicles for human organs that then can be translated without being rejected by the human body. What does it mean if we put if we grow a human brain, for instance, in a pig embryo? What does it mean for a Muslim population if an organ that's been grown in a pig is now being implanted, and so on? So the ethical, legal questions that arise from many of these questions, aside from the historical baggage that comes with chimeric beings in Greek mythology and elsewhere, you already see where most of the questions are not, is this going to be safe and can we scientifically do it? Because we can. The questions are, should we be doing this? Which brings me to the most obvious application that actually seems innocuous in certain ways, self-driving cars. Go to Phoenix, Arizona, they're everywhere, and more than once have they run over people. And not because the neural networks in these cars cannot tell that these are people. In fact, they can tell, and they still run them over. So raises a whole host of questions. Regulatory questions, meaning, can we sue an algorithm? Can we sue the programmer? Who is at fault for doing this? Is it the regulators that didn't look into this? Has it been hacked? This is research that's been done at Carnegie Mellon. This is a stop sign. Everybody in this room would obviously look at this as a stop sign. Most self-driving cars, the neural networks read this as a 45-mile-an-hour sign. And it's simply because there's a couple stickers here, here, and here. So it's really easy to hack these things, not by rewriting the code or having computer viruses, but simply by putting a bunch of stickers on a stop sign. And that, of course, brings up the final issue, and that is we're selling a product right now, and we're researching a product, and we're improving a product, and we're pushing toward widespread application of product that is designed to kill the user in a very narrow set of circumstances. All over the country, and I'm sure this university does work on this as well, how do we train these cars to make moral choices? They drive down the street, there's an elderly couple crossing the street, there's a kindergarten class on the sidewalk, and there's a patch of black ice, more realistic in Wisconsin than it is here. But car goes out of control, spins. What does the car do? Do I kill the elderly couple? Do I take out the kindergarten class? Or do I maybe, is it the best moral choice to kill the driver? And in some circumstances, of course that's the best moral choice. You are, I'm sure, better people than I am. I'm not sure I would make that moral choice if I was the driver, right? Steer myself into a wall to protect everybody else. The car will make that decision for me. So we will tell parents at some point that that car that they're buying for their son or daughter is actually designed to kill them. Long story short, what we're having is we're having a debate around larger scientific issues that we're ill-prepared to have, and that will be largely based on the ethical, legal, and regulatory questions that come out of the science. Then they're based on the scientific facts surrounding these issues. Alan Leshner, who is the former CEO of AAAS, the American Association for the Advancement of Science, has spoken to this quite powerfully. And he reminded, this is now almost 15 years ago, more than 15 years ago, he reminded the scientific community that really effective communication with the public has little to do with talking down and explaining the science to them, because if they only understood the science, they would make better choices. What it is about is having what he called an honest bidirectional dialogue. And science broadly has embraced this and have said, yes, we need to have this dialogue. But typically, scientists end up after the first half of this statement. And they don't read the second half, and that is, we need to have a discussion not just about why science is exciting and why these new technologies are important. We need to have a discussion also about the perils and the pitfalls. Should we create chimeric embryos? Do we want to have AI broadly deployed in transportation and so forth? And so that's kind of the debate that we need to have, and that we've had a really, really hard time implementing. And this is, especially in countries like the US, easier said than done. And the reason why I mentioned the ideas of chimeric embryos and CRISPR, meaning genome editing techniques, is because the US is a unique country. This is data from Pew, but other people have collected similar data. On the x-axis, you see an admittedly poor indicator of development, and that is GDP per capita. But you can put other ones there, it's just for the sake of simplicity, so this is between 0 and 50,000. And then here's the percent of the population that self-identifies as very religious. And you can see how basically there's a nice curve, the more developed, and again, I fully acknowledge that this is a poor indicator of that, but the higher GDP per capita, the lower the percentage of the population itself identifies as highly religious. So you have Pakistan, Senegal, and other countries up here, and you go to Australia, Canada, Germany, Britain, and so on down here. 2 countries that are literally off the charts. One is China sitting down here, and then the other one is the US up here, which, again, really high on levels of development, but also fairly high in terms of the percentage of the population itself it identifies as very religious. That's not good or bad, that's just a reality. And it's a reality that touches on a lot of the issues that we're dealing with. Stem cell research, Matt mentioned the Morgridge Institute for Research and Tissue Engineering in the introduction, CRISPR, and so on and so forth. And this is where we as a scientific community that tends to be a lot more non-religious or even atheist than the rest of the population routinely run into problems. This is Neil deGrasse Tyson, who some people see as one of our better science communicators, tweeting on Christmas Day, on this day long ago, a child was born who by the age of 30 would transform the world. Happy birthday, Isaac Newton. Funny? Absolutely, but trolling Christians on Christmas may not be the best way to open hearts and minds, especially on an issue where I'm trying to reach them, right? I'm trying to reach them on issues where their value system or our value systems very often, it's not us versus them, but our value systems very often are at odds with what science enables us to do. Michael Mann, one of the most prominent climate scientists in this country at Penn State, tweeting routinely that nobody with an R next to their name, meaning no Republican, is safe to have in Congress. Again, if I'm a climate scientist and I'm trying to reach conservative audiences who think that climate change is basically a Democrat strategy to get regulations through that they couldn't get through electorally, this is not the way to do it. And of course, my all-time favorite, Richard Dawkins, who just mocks everybody who either has concerns about embryonic research or religion, also holds a chair in science communication at Cambridge, ironically. But the problem with that being scientists very often probably don't engage in the most fruitful discussions and or two-way dialogue that Alan Leshner called for, because they're knowingly or unknowingly stepping on the very values that science challenges. And as a result, end up closing doors that they shouldn't close. And the problem is getting worse. This is data that we collected in national survey data. We randomly assigned people to conditions, about 700 people each, and we asked them at the same time, but randomly assigned about different technologies. The reason we randomly assign them is to avoid what we have called spillover effects, and that we've documented again and again, meaning I ask you about one technology and your attitudes on genetic modifications of plants and animals, for instance, bleed over or spill over into other technologies. So we asked people separately about nuclear technology as a legacy technology. Does that conflict with moral or religious views? Does it blur the lines between God and mankind or humankind? And for nuclear, you see some resonance on that on a 10-point scale, but not really all that much. Nanotechnology, of course, is a technology that really started pushing, bless you, some boundaries, meaning it basically allowed us to create materials that don't exist in nature. So for the first time, we actually had a technology that challenged that a little bit more. And then for synthetic biology, and this is J. Craig Venter in 2010, when he inserted synthetic DNA. So this is DNA made in a lab, written from scratch into a live bacterial cell, and created what he called life in the lab. What other scientists said he jump-started life, but you can already see J. Craig Venter, Frankenstein in here in the test tube, and I'll come back to that idea a little bit later when it comes to why Frankenstein in particular and the idea of framing is such an effective tool for communicating. But long story short, this is where, and CRISPR is just the logical extension of this. And I'll show you some data that we published in Science magazine a little while ago. This came out of a National Academies Committee on the science, ethics, and governance of human genome editing. So this was a committee, and I was a member of it, that was chaired by co-chaired by an ethicist and a geneticist, and basically dealt with a lot of these issues. Surrounding this report, we asked in a national survey if people thought that human genome editing allowed humans to play God, or if it messed with nature. And you can already see that some of the numbers that I showed you in the previous slide, this is a separate survey, are now at 55, 66%. So we're really beginning to see widespread resonance around these ideas and these issues across the board, pushing ethical, moral boundaries. The interesting thing is when you ask the same thing for wildlife, it gets even more extreme, and not in a good or bad way, but simply the attitudes become even more pronounced, because I'm now piling on top of one another value concerns and concerns from environmentalists and other groups. So in other words, I'm really bringing together opposition based on values that I may be violating for different groups, and that have a cumulative effect in terms of public opinion. So, long story short, the setup of highly fast-moving science that is has huge ethical, legal, regulatory concerns and really is beginning to push value judgments by all of us and scientists, sometimes trampling those unintentionally or intentionally with their feet. The last problem, to just set up that first part that I want to mention really quickly, are the trust deficits that we're seeing. This comes out of the same data that I just showed you on CRISPR. When we ask people how much they trust as information sources, we ask a whole bunch of them. I'm just showing you 3 here. University scientists, agencies, and then religious groups. And broken down the respondents by highly religious, medium, and then low religiosity. If you do a split in the US population, it pretty much means you're not religious at all. That's the low group. So for university scientists, again, you see some difference here, and same thing for religious scientists, but that's not the surprising part. I think we all would have intuited that. The surprising or the interesting part is, if you look at the dark blue lines, they don't really differ significantly across the 3 groups. So in other words, we as scientists don't necessarily have any advantage in terms of being a more trusted information source for some groups in society, which means everything that I just outlined, meaning the nature of the issue, the violation of value systems, and the way we tend to behave when we communicate publicly, become even worse because we don't have an inherent advantage, and we're basically shooting ourselves in the foot in the process. So, to make it all even more complicated, all of that comes at a time when I think the polarized nature of our public debates and human nature, human nature's role in this has become even more pronounced. And many of you have heard about motivated reasoning. I just want to take a little bit more of a differentiated stab at this, because very often motivated reasoning is being described as and I'll get to this in a second, but as something that people engage in who are not interested in the truth, but are interested in tribal thinking and identity protection. And there's some truth to that, but I think Jamie Druckman at Northwestern has written about this recently fairly powerfully, where he's basically saying very often we end up with the wrong information based on absolutely accurate or accuracy-focused motivation. And the example here, this is again more of a Wisconsin problem than it is a Washington problem, but vitamin D and you live far enough north, and your nutritionist tells you that you should take vitamin D because this is really important, and you don't just get enough from sunlight, especially during the winter months. And typically those recommendations, not typically, but sometimes those recommendations don't match up exactly with what, for example, the National Academies of Sciences, Engineering, and Medicine have recommended in terms of dosage and in terms of when it's really warranted. So if I turn to this, I'm probably going to take a much lower dosage and much less frequently than if I go talk to my nutritionist who tells me something completely different. Both of them, I have absolutely accuracy-oriented motivations. There's nothing sinister, tribal, or directionally motivated in that. What is directionally motivated is the general idea of motivated reasoning that we've known from political psychology since the 80s, late 80s. And very often, I'm delineating this because I think the literature very often just throws them together, and I think that's misleading. Selective exposure is not motivated reasoning, in spite of recent literature sometimes throwing them together. Selective exposure is Festinger in the 50s. It says, I am seeking out information that fits my prior beliefs. I am not even reading things that I don't agree with. Right? If I'm a liberal, I'm not watching Fox News, which means I don't have to motivatedly reasoning about Fox News because it never reaches me. I put Flipboard here, put any other selection mechanism, if that's Feedly, if that's other news curation, news diets on cable, and so on there. The idea of motivated reasoning, though, is a different one. It basically says, if I'm exposed to views that come to me regardless of what the source may be and what selective exposure may be. Let's assume all of us in this room agree on 10 facts. I line them up here, 10 cards with 10 facts. We all know they're true. All of us will still draw slightly different conclusions from those facts. Why? Because we will engage in what's called confirmation or disconfirmation biases, meaning we will weigh more heavily those facts that fit our prior beliefs subconsciously, and we will weigh less heavily those facts that don't fit our prior beliefs. If you really like Trump, you will look at a statement from Trump very differently than a Democrat would who might not like Trump and who will read the exact same statement very, very differently. The tricky part is this term, biased assimilation. We end up assimilating reality into our belief system rather than the other way around, right? Democratically, you would assume I constantly adjust my belief system based on the best available new information that comes my way, but that's not what motivated reasoning says. What motivated reasoning says, the best available evidence that comes your way, I'm going to engage in confirmation biases and I'm going to assimilate that information into my belief system, interpret it in ways that doesn't threaten my belief system so I can protect my tribal identity. And that seems like something that we can totally be judgmental about, but I'm going to urge us to not do that, and partly because of the issue of stem cell research. This was George Bush, as you may remember, with snowflake babies, as they were called at the time. So these are leftover embryos from IVF that sometimes parents allow to be used in research, that sometimes get discarded. And under an initiative by the Bush 43 administration, were actually used for adoption. So parents could adopt a fertilized embryo, have it implanted, carried to term. The reason they were called snowflake babies, because or why that term was used to say, well, they're unique, like snowflakes. Every single one of these embryos that scientists want to use for stem cell research could be a baby. And every single one of us in this room understands what the moral dilemma is. No matter what your stance is on embryonic stem cell research, you will understand what the dilemma is. You will also understand Michael J. Fox, who's saying we need this kind of research for Parkinson's and to cure debilitating diseases. The problem with motivated reasoning is that the exact same facts will mean very different things to different people. Now, that may be one thing in politics, and for issues like abortion, where a lot of it comes down to moral judgments and political judgments. And again, this is probably too much of an ongoing issue right now. I just saw that the governor just signed the Alabama bill. But for science, it's a real problem. The fact that the same scientific facts mean different things to different people is a novel problem, or one that, at least at the scope that we're seeing it at the scale, is a novel problem. I want to show you an example from Wisconsin. And of course, at Wisconsin, it's a fairly liberal campus, well known for that. And we had a governor, Scott Walker, for a long time, who took $300 million from the UW system and gave it to the Milwaukee Bucks. Which I guess worked out there in the playoffs, right? I think. I don't do basketball. But that's what he did also in the process is this took a bunch of matching money that the state had committed to a large Department of Energy grant that we had on biofuels. And the response at the university was as swift as it was not understanding what was going on, because our response was, how does he not get how devastating this is for the state economy? Taking money that's out of one of the biggest economic drivers, meaning the university, and its research. But what we had at the time, we had a project in the field with the Corn Growers Association at Wisconsin. Also a very Wisconsin thing to get your research funded by the Corn Growers Association. Well, we asked how much information people got about the issue of ethanol and biofuels. So this is now, I'm just showing you a simplistic plot of an interaction. There's obviously lots of controls for other demographics and other confounds. And then I just plotted here, do people think that it has a positive effect on the economy, biofuels, or a negative effect? So the more information people get, and for Democrats, the more information they got, the more excited they got about biofuels. Right? And it didn't matter if it came from newspapers or television. And you can already see the white space is here for Republicans. And it goes in exactly the opposite direction. Neither one of them is right or wrong. But they both take the exact same information about an emerging technology, and they draw opposite conclusions. So two things that are really important here. just putting more facts in front of people and for motivated reasoning very often just ends up polarizing. And this is really the important part, the group that's most polarized is also the one that's most knowledgeable. Typically, polarization doesn't occur, and lots of other people, Dan Kahan at Yale, others have shown the same thing. The highest level of polarization tend to occur for the groups that are most knowledgeable, have the most integrated ideological frameworks, because for them everything goes on a shelf, on a very well-developed shelf system that allows them to quickly, basically motivatedly reason their way out of anything that doesn't fit their prior beliefs. Right? So, and this is at least one person you guys should know, some of you will know, Mike Xenos, he came out of this program, but when I said earlier, these are two of my frequent collaborators, Dominique Broussard, who is our department chair, a trained geneticist at the master's level and a PhD in communication, and Mike Xenos, who comes out of political communication. I think Lance Bennett student when he was here a long time ago, just looks really young. So we are currently starting an NSF grant that's trying to reverse what I just showed you in the previous slide, meaning how can we create these broad deliberative exchanges, these broad discussions among the public and depolarize them from the get-go, meaning avoid that polarizing effect that as we're having more conversations and we put more information in, where we don't end up with this wide polarization. So and this is seed data that led to this NSF grant that we're just starting now or that has been going on for a half year. And what we did here is we basically put undergraduates in 4 different groups. This is a simple experiment on a non-political issue, nanotechnology, right? It's not polarized, it's not polarizing, there's not partisan divides, and so on and so forth. What we basically did is we gave people a bunch of questions on nanotechnology. So again, modifications 1 to 100 nanometers, small molecular changes. And then we said, well, we're going to eventually, after this experiment, we're going to put you in a discussion group where you will have to discuss the issue with other people. There were 4 different conditions. One, the control, they were not told that they had to be in a discussion afterwards. So they just basically went through the experiment. One group said you have to talk to, well, let me start here. You have to talk to others, but we didn't tell them what the others would look like. You have to talk to others, and they're going to be similar in opinions to you, meaning you're going to talk to your tribe, or discussions with others that will have opposing viewpoints. The discussion well, it did take place, but only so that undergrads wouldn't go off and tell their friends that they didn't have to discuss. So the discussion itself didn't matter. What we cared about is the threat of discussion. This goes back to Phil Tetlock's work at Penn, Mike Roloff's work at Northwestern. This basically said that if I can create a sense in you of social accountability, meaning you will have to talk to other people that are not like you, you will end up engaging in very different types of information seeking and processing than if you're basically free to engage in whatever motivated reasoning and tribal thinking you're allowed to. So it's a pretty weak manipulation if you think about it, right? We're only telling them that they will have to discuss. That's all we're telling them. What we then do is we basically say, now go off and look at a bunch of information before we ask you a few follow-up questions before the discussion. And then we create a gated information environment where we're saying you can either spend time on general news. So basically there are articles from general news of, I don't know, 8 articles. There are 8 articles from Science and Medicine, and there are 8 articles that show both sides of the issue, meaning that really pull in both sides, not just one in a motivated reasoning sense. And then we simply track what they do in that gated information environment. So gated means they can't go outside online to other websites, they have to stay in there. And this is the important part. So this is just the percentages of where they go first in terms of 2-sided information versus everything else. 2-sided information in all the groups that are threatened with discussion, much higher than in the no discussion group. So simply threatening people with discussion already drives their 2-sided or their more 2-sided information processing and seeking. And then, of course, if you look at the ones with opposing viewpoints, that's actually where that number is highest. Is that evidence of countering motivated reasoning? No. Is it evidence that suggests that the mechanism works? Absolutely. And so, as I said, this is seed data, and this is what we used as a starting point for that NSF grant. But I wanted to show you that there's lots of work beginning on how we actually create better democratic decision making in spite of our human tendencies that push us to do the exact opposite. So let me get to the third point, which is how emerging media systems tend to not help. And I used to be able to explain this to my students much better, but now my students are of an age where they don't understand what it means to read a newspaper or to look at an article that doesn't have likes or retweets or comments underneath it. That just has never existed for them. Right? But there used to be a time when I read the newspaper, and the hotel here still has print newspapers, and I took a picture. They still have print newspapers, and I'm sitting there, I'm reading the article, and I have no idea what anybody else thinks about the article. And I have no way of telling. That's what used to happen. Now I have immediate cues for every single article, tweet, Facebook post, anything else, of how popular it is, how often it's been shared, and so on and so forth. It's impossible for me to not immediately judge any YouTube clip of how good it must be because nobody has liked it, or 1,000 people disliked it and only 3 people liked it, and so on and so forth. Those are social endorsements, absolutely, but they're also tribal cues in terms of who likes them, who among my friends like them, how did they get retweeted, how did they get commented on. So one of the things that we were interested in, and this is a project a few years ago, we wanted to know what happens if we put information in front of people that doesn't differ in the content. So this was Vancouver Sun, went Canadian sources. Hopefully that would be less ideologically colored than some of the US sources. Canadians are neutral. And then we basically put that in front of about 3,500 people in a national sample, where we basically everybody read the exact same story. This is again a story about nanotechnology, nanosilver, shouldn't be polarized at all. What we did change is we changed the comments. And so these were manipulated comments that made the same arguments in favor or against using nanosilver and cleaning products and so on. But one condition was very civil and the other one was very uncivil, meaning one condition people disagreed on the facts, and the other one they still disagreed about the facts, but they prefaced it by saying, what kind of an idiot are you? This is obviously wrong, and here's why, all the facts. So that's the uncivil versus civil condition. Why is this so important? Because there's no substantive difference in content. The only difference is how we talk to one another, what the tone is of the discussion. If the tone of discussion goes south, if the discussions are uncivil, people were significantly more likely to see bias in the article itself. They read the exact same article. There was no difference. But if they read comments that engaged in yelling and screaming afterwards, they inferred that if there's smoke and there's yelling and screaming, there must be fire, meaning something must be wrong with the article. And number 2 is the people who read the article followed by the more uncivil comments also ended up being more polarized in their attitudes, meaning people who had supported the technology before supported it even more, people who opposed it even more. So you have to let that sink in a little bit, because nothing of that is a content effect. It's all simply a perception of the tone with which we talk to one another, influencing readers who come to the article later on and look at this yelling and screaming and make a judgment from other people's comments about how good or bad the article is. And that wasn't lost on news organizations themselves. And just to illustrate the point of print, this was the very first, and news values and everything else, this was one of the first articles that was written in the Milwaukee Journal Sentinel about our study. Really good science coverage, sitting at the bottom of a page just before the weather with a jump, just in case anybody was tempted to read it. Now nobody will read it. This was the online version. Aside from the fact that some A/B testing led to a slightly different headline, this is my point about social endorsements, right? I know immediately, 2 hours in, that 170 people commented on this story, that 1,000 people liked it on Facebook, and for some weird reason, 2 people Pinterested it or pinned it on their pin boards, whatever that, I don't know what that is. But that really makes the point. But what made the point even more, and I thought that this was still one of my favorite, are the comments on our study. So this is all these studies by pointy-headed scientists. 99%, this is us, right? This is us as researchers, 99% of whom are socialists and communists. Wisconsin professors bewildered by science opinion being questioned rather than being accepted as told. Not really, but still. And this is my favorite one, because anybody who comes up with findings like the ones we did must hate God and country. I was still the favorite. The funny thing about this, of course, is that the irony was completely lost on the commenters that that's exactly what we're doing research on. It was not lost on The Onion, and I don't have to see. This is the pinnacle of my academic career, was being in The Onion, and The Onion taking a shot at comment sections. The Onion also, I would like to point that out, wrote by far the best summary of the social science of our study, of any news outlet. And that includes the New York Times, and I think the New York Times did a good job. But the Onion, whoever they didn't smoke that week, I'm pretty certain, because that was a good summary. But we wrote about this in the New York Times at some point, and basically said, look, we may have a problem for news organizations, and because this is the very essence of what explains some of the declining levels of trust, right? The idea that simply by giving ourselves a forum to be bad citizens, we're destroying potentially the perception of the very product of journalism. And Popular Science, one of the higher circulation science magazines, as a result of this discussion, ended up closing their comment section in a very highly publicized, especially in the science communication, decision, which of course then kicked off another discussion where people basically said, well, this is against freedom of speech, and these comment studies out of Wisconsin are basically undermining people's right to free speech, which I disagree with for a variety of reasons, but it was a good discussion nonetheless that Pam Ballock, I think, summarized really nicely. But by that time, the dam had really kind of broken, and eventually the Chicago Sun-Times, Reuters, CNN all ended up closing their comment section, simply saying it's so expensive to moderate comments and to avoid that nasty effect, as we ended up calling it. This is actually an editor from the New York Times came up with this. But that even when Reddit came up with their new, at the time, news site upvoted, even they didn't allow comments on a Reddit product. Think about that. Reddit doesn't allow comments. That's what Reddit is. It is comments. And even they were saying, look, this may not be the best idea. One of the things, and this previews a little bit of my conclusion, one of the things that I think we're doing really well in communication is identifying problems, and one of the things that we do really poorly is doing research on solutions for large societal problems. Us included, meaning our research team included. We talked to news agencies and newsrooms all over the country and the world, for that matter, about this effect, because everybody was concerned about the same thing and asked us the same question: how do we fix it? And our response was like, well, we don't really have any research on that, because we haven't just done that yet. So what we did in a subsequent study, we replicated the effect. And this was Sarah Yo. This just came out last year. And I just want to show you one, because it's a really cool effect. And there was just a piece in PNAS and Proceedings of the National Academies that did something somewhat similar or consistent. And basically, so this is the nasty effect, right? The more uncivil comments get, the more people see bias. So this is the dotted line. The solid line, though, is a group where we had the exact same blog post, the exact same comments, except for we inserted one line and said, this comment has been removed by a moderator. So we simply gave the impression that there was a parent in the room. Of course, there was no real moderation. There was fixed comments that were just in two experimental conditions. So the only difference between those two groups is that in one group there was the perception that there was some form of oversight. The moment you give the perception of oversight, that nasty effect becomes a lot less pronounced, and in fact it's not significant anymore. So in other words, it becomes a lot more moderate, simply because people think, well, yeah, they may be yelling and screaming, but at least somebody's watching. So maybe the article is not as biased after all as I thought it was, because that's really the highly problematic effect, right? So the ethical issues for journalism, of course, are a different question, meaning I'm telling my readers that there's moderation even though there is no moderation, just to avoid that nasty effect. That's a different question, but at least the mechanism functions. So for the sake of leaving enough time for discussion, I want to just talk about a few intentionally provocatively phrased conclusions that you can hopefully totally disagree with me on, and we can have a conversation about this. But political science, I think many people in communication would love to be psychology, sociology, political science, and we just so desperately want to be a real social scientific discipline. I told you it would be more somewhat provocatively phrased. But there are also lessons to be learned, because political science has a long history of being targeted by people like Tom Coburn and others as a target of withdrawing NSF funds that go to the social behavioral and economic sciences. And this started, it didn't even start, but certainly first bubbled to public forefront in 2009 when they really went after the SBE budget of the National Science Foundation. And political science had to engage in a little bit of a soul searching about how relevant they really are. And I think there were people who were saying, how do they not understand how important political science is? And there were others like Peter Katzenstein at Cornell, who also happens to be a fellow German, who said this. And the only thing I disagree with him is the beginning of this, that grad students, because I actually think grad students are not the issue here. Grad students are the ones who do very often think about the larger problems. I think the problem are those of us who obsess over the fourth decimal point of a multinomial logit rather than the larger problems. And this is exactly what Peter Katzenstein said. If we don't make contributions to the large, sloppy, unmanageable problems of our time, the problems that don't have easy solutions, and we may never solve them, but if we don't try, we're not going to think back to the cheesemakers, the large problems that society faces and that we as universities are making contributions to. And so he basically took his own discipline to task and said, if you guys don't tackle the big questions, you shouldn't be surprised if society asks you why you exist. And I think to some degree, communication sometimes has a little bit of the, and I'm saying this having been trained within the discipline, working within the discipline, and publishing very often within the discipline. I think we have some similar issues, and I think we have a high tolerance, and I picked 3 areas here that are all solidly in my wheelhouse, meaning I've done exactly what I'm accusing the discipline of doing, which is why I'm singling those out. I think one is we have an unbelievable tolerance for contradictions. We will let strands of literature proceed that directly contradict each other. A lot of people at Wisconsin have for a long time done research, including myself, that shows that heterogeneous networks of people that are full of non-like-minded others, that expose me to ideas that are not my own, that challenge my viewpoints, that those are good for participation. They make me more efficacious. They make me seek more information. They make me more participatory. Diana Mutz at Penn, who used to be at Wisconsin, has a line of research that says the exact opposite. That says if you're exposed to polarizing information, it may make you apathetic. It may create cross pressures that basically make you stuck and you don't know what to do and you don't engage in political activity anymore at all. Have we resolved it? Some people have tried to, but we've basically tolerated this as 2 lines of research that each are well published and each are directly contradict the other. So I think that's one, what I call intradisciplinary contradiction. But I think there are also a lot of interdisciplinary contradictions. And framing, I think, is a really good example. I showed you earlier the idea of Frankenstein and Frankenfood and the Franken label. Why is it such an effective tool of communication? Because I don't give you a single fact. I'm not persuading you of anything. All I'm doing is I'm connecting a technology, if that's synthetic biology or GMOs, to a mental bucket, to science going too far, putting stuff together that doesn't belong together, transgenics, that stuff getting, and Frankenstein screws through his head, right? Not Frankenstein, Frankenstein's monster. The monster getting out of the lab, all of that because of scientific hubris being impossible to rein in, and you can see how the metaphor works perfectly for things like GMOs and others. So, why is framing such an important thing? Because in our discipline, we treat a lot of things as framing that a lot of other disciplines don't treat as framing. If you look at the early Kahneman and Tversky work that ended up winning them a Nobel Prize, it's a very narrow slice of equivalence framing that doesn't line up with most of the framing work we do in a discipline. Does communication care? No. Do they care if we're understood by psychology and by behavioral economics? No, we don't. We just continue. The fact that we don't have meaningful conversations across, and again, I told you it would be provocative and simplistic, doesn't necessarily matter to many of us. And Shanto Engar and I have written about this in a bunch of places, but we can come back to that. So that's what I would call interdisciplinary contradictions. And then I think the last one is, and this is especially as we're doing more and more computational work, is we're doing a lot of work that is not concerned at all with media effects, meaning with real influences. What we're doing instead is and this is the infamous drunkard search, right? The person who's crawling on his knees under the streetlight and the cop is asking what he's doing, and it's like, well, I'm looking for my car keys. And it's like, where do you lose them? He's like, well, over there, back next to the bar. So why do you search here? Well, because the light is better. And we do the exact same thing when we do yet another, and again, this is work that I've done, another analysis on Twitter, because Twitter is publicly available. And we don't do analyses on interchanges on Facebook, for instance, that are behind a password wall. Why? Because we can't get to the data. But people like Solomon Messing and others, of course, have demonstrated quite convincingly, I think, that a lot of the exchanges that we have behind paywalls, behind password walls, rather, with sources closest to us, family sources, have a much higher chance of getting non-like-minded information across than others. So this is really where the effects are. Instead, we're looking on Twitter, which is used by a very narrow slice of Americans, simply because it's available, simply because this is where we can program the API. Twitter is not as bad as Facebook, that they change their APIs all the time. So it's easier to scrape and so on and so forth. And it's ultimately not the most productive move forward. So the general idea of us engaging in methodological convenience rather than finding the best available data for the phenomena we're trying to test, I think is the third one. And then, of course, just because I like South Park, I think we're doing a lot of the same studies again and again and again. The framing is probably a really good example that's close to my heart. The third person effect, same thing. We've known since 1983 that it exists. And there's important strands of research surrounding it, but we keep coming back to a lot of the same studies that probably are not always as useful. So I think I want to leave with three ideas that I think we're going to be asked as a discipline, more and more. And if you haven't read it, there's a great piece by Duncan Watts in the inaugural issue of Nature Human Behavior, where he basically calls for solution-oriented social science. And now that's easier said than done for somebody like Duncan, who works or still works for a couple more weeks for Microsoft Research. He's going to Penn as an integrated knowledge professor. But I think the article is well-reasoned. It's not just you guys need to be more application-focused. It is really a well-reasoned overview of the constraints of academia and everything else. And of course, if you think about where the origins of our discipline lies, both in terms of the data sets that people like Lazarsfeld and others used for women's magazines and very applied problems that they researched, but also to what I showed you earlier, the land-grant university and the idea of teaching, which is what the congressional language said, teaching farmers to grow 2 blades of grass instead of 1. So a very goal-oriented background to the kinds of work that we've been doing. I think there are lots of other indications why this has been from day one in our DNA. Nola Neumann, who I mentioned, my advisor in Germany, got a degree in newspaper studies. That was actually the degree when she studied in Berlin. So I think that's number one. I think we really do need to start making contributions much more than we have in the past to the larger societal problems. I think we need to think about the foci of our discipline and what that means. Maybe communication needs to continue to exist. Maybe it's going to be an information science and communication field. Maybe it's going to be something else. We have tried to do some of that work with the standing committee that Matt mentioned in the introduction for the National Sciences Academies of Sciences, Engineering, and Medicine, the standing committee on science communication, research and practice, where we're trying to map the discipline. And Jevin West, actually, who's here in the information school, has done great work for us, helping us kind of do the citation pattern and kind of crawling side of things. So that's, I think, the second one. And I honestly don't have an answer for you where I think communication will be. I can promise you that it doesn't look like the way communication looks like at Wisconsin, where we have 3 different departments and 2 different colleges and 50 different degrees that cut across or don't. But the last thing that I'll mention is I think it has huge implications for how we train students. And I chaired a committee at Wisconsin on the future of undergrad education and how do we prepare students. That was one of the key questions we asked ourselves for jobs that don't exist yet and that we don't know will exist. So why is a Washington degree, why is a Wisconsin degree, why is a Harvard and why is the UCLA degree, why are they worth anything 20 years from now when most of the media tools that we're teaching, when most of the other things that we're teaching will no longer be around? And what does that mean for how we educate children? Google, of course, when they bought DeepMind, the first thing they did is they created an ethics board, which was a bit of an interesting exercise, and we can raise questions about how successful that was or not. But the reason they created this, not because they knew what they were doing and where they were going, but because they didn't know where they were going. That's what they were saying very explicitly. And I think we're a little bit in the same spot with higher education, that we don't really know where we're going, but we need to prepare students to go there. And in communication, I think that challenge is probably more urgent than it is for most other fields. So on that really optimistic note, I'm going to leave it at that. Thank you so much for having me.
Terrific. Thanks very much, Dietram. So we have plenty of time for questions. So why don't we just get started? And Dietram, I'll let you.
Sounds good. Yeah, I'll let it out.
Yeah, polarization. I didn't hear the cliche glass half full, half empty. Congratulations to you on that. My question really is a what-if situation. You have 3 participating groups. They're given a set of facts. They are asked to predict the outcome of artificial intelligence on humanity. 2 of these groups are polarized groups. The 3rd participant is AI. What do you think is going to happen?
The 3rd participant, is AI. Well, so here's the tricky part. You're asking somebody who doesn't program AI, and the funny thing is if you ask people who do program AI, they sometimes don't know the answer either. A really good example is DeepMind's AI, for example. If you show it a picture of a retina, of a human retina, can with a 95% certainty predict if that retina is from a male or from a female. No human doctor can do this at all. The interesting thing about that story is not that. The interesting thing about the story is that the engineers at DeepMind don't know what the algorithm actually does. So they don't know either. They just know that it does it with a 95% certainty. And so a lot of that work is actually still black box. Why? Because it's basically capacity, and of course, we're constrained by our life cycle, by our lifetime, meaning we have limited capacity as human beings, and we have limited capacity computationally in our brain. Now those constraints are largely gone. When we work with we just finished a white paper for DeepMind, and when we work with them, we're saying, well, so what kinds of experiments and online assignments do you do? And they're like, well, we don't do that many because it's really expensive. It's actually hundreds of millions of dollars sometimes. And our question is, how do you spend hundreds of millions of dollars on an online algorithmic experiment? And the answer is, it's so much computational power, and it's computational power that comes from the same servers that our Gmail runs on and all of our Android phones run on, that it's actually not that easy to do. So long story short, I don't know if AI comes to a better conclusion. There's a bunch of indicators that says we're not quite there yet. One was the Facebook example where the 2 bots started talking to one another in a language that they were allowed to develop. And Facebook forgot to tell them that that language had to be English or human. And so they started developing their own language, and eventually the programmers couldn't understand it anymore and turned it off. There's another episode where Google had their AI tested in stressful situations, and it became more and more aggressive in all the stressful situations. So they also didn't proceed with that. So I think even in AI, we're ways away from ideal decision making. And partly, then this is the last thing I'll say, of course, it's because AI is only as good as the training. I mentioned the moral choices that cars make. They're basically trained by having human coding and forming an algorithm. And the same thing, of course, is true when it comes to AI being able to predict race or identifying rather facial features. And the fact that Palo Alto is not the most diverse place under the sun, and so the AI is much better at picking certain racial groups and facial features than for others, because that's where the learning data comes from. And so I think I'm at this point not very optimistic yet that AI is going to come up with a better way of predicting it. It certainly is going to take more information into account, just because it can. But that's certainly the next really, really big issue, I think, across the sciences, including genetics. And if you look at where Google is investing in basically 3 different fields. One is genetics, and they've hired a lot of really good geneticists out of UCSF and elsewhere. And 23andMe, of course, was founded by the ex-wife of Sergey Brin, co-founder of Google. The second one is AI, meaning how can we use machine learning to make sense of large patterns of DNA, much of which we don't understand in human DNA, for instance. So I need, ideally 7.5 billion people and all their DNA to fully get at the patterning. And then number 3, data, meaning if I know all your data from all the searches you did, and I have to pain here in my side, and maybe it's kidney. I don't know if that's what my kidney is, whatever. Maybe it's kidney something, and then if you have all your health data, all of us with our Apple Watches, that are constantly producing data. If I can put that together with your genetics data, with your AI, so that's where Google is going in terms of actually being able to make better predictions for personalized medicine, and I think that's where the future is going to be. That was a long answer to it. A shorter question. Go ahead.
My question is how to communicate to the public effectively something scientific findings that might be so challenging, that might challenge some fundamental beliefs. For example, in the future, I can imagine that we will have perhaps evidence, scientific evidence, to show that free will is perhaps just a result of biochemical processes, that people do not have free will at all. It's just a myth and fiction. How would you like to communicate that idea to the public?
So when it comes to communicating things to the public, I think, and again, I would say to the public, I would push back on two elements of that. One is there's no single public, right? There's lots of different publics. And I mean, you can slice them in so many different ways. I think publics are highly dynamic. And then I'm not sure that I would argue even that we should communicate to the public. Why? Because it assumes that we have the right answer and other publics do not. When I say we, I mean the scientific community. That is true for scientific facts, but that's not the problem with the question that you're raising. Right? The question is not, do we know that, and is that now biochemically or however else proven? The question is how does that challenge our value systems, and how do we translate that into policy and other things, or into our sense of self-worth or whatever else? So I think it's really the question of how do we communicate with various publics about this, and what are the outcomes? So the question is, for the scientific community, what are the conclusions? And two things. One is the question is, should we move ahead with research that finds things like this? And here's where I think there's a scale, right? And that scale, using Alan Leshner's example of the bidirectional dialogue, I think most scientists now will embrace that model and say we need broad public engagement. What that could mean at one extreme, though, and Vicki Colvin, who used to be at Rice as a toxicologist, she's now provost at Brown, I think. She was at stage at one of the first colloquia that we did on science communication, and she basically said, if you want engagement, you need to be ready when the public tells you to shut down your lab. You need to be ready to shut down your lab. Otherwise, it's not an honest bidirectional dialogue. Otherwise, it's still you telling the public what you want to do. And if we're honest, most of the things that we do as science communicators is exactly that. If we talk about, we do science on tap, we go to a bar, we're really jovial, we talk to people. Doesn't mean I'm going to close my lab. I don't really care what, and a lot of scientists will say, I don't really care if they tell me to close down my lab, I will still not do it. Ultimately, they see it still as an educational exercise. And I think that's where our problem comes in, that a lot of, I think your example is a really good one. The chimeric embryos are a really good one. The idea of us getting to the points where really our comfort zone is, where all of us are getting to the limits of our comfort zone. For me, think about AI. That's where I'm sure that AI can do research better than I can eventually. Right? And so then people say, well, there's human creativity. That's exactly what DeepMind is working on, right? Can we replicate all these things? So for me as a researcher, I may be totally obsolete. Do I like that idea? No. But I think when you say, how do we communicate that, I think this is exactly why we need those broader public debates. Should we have preemptive policing, the idea of pre-crime that I showed you? Every police person, many policemen will tell you, or police officers will tell you, that's a good idea. If I know what the risks are going into certain situations, that improves the chances that I will go home to my family tonight and still be alive. If I'm a person of a particular racial group or who lives in a particular neighborhood, I'm going to tell you that's the worst possible idea that's directly at odds with issues of human dignity or the Constitution or whatever else. So, and this is what when I said wicked problem at the end, most of the problems we're dealing with don't have a best case scenario outcome. Right? For climate change, there's a whole host of outcomes, a or of strategies forward that we could engage in, all of which have upsides and downsides. There's no way of moving forward on climate change that doesn't require some compromise of some sort among all of us. Same thing is true for any other issue. So I think ultimately the question is, how do we as a society have a broader discussion about these wicked problems and about, relatively speaking, the best path forward, because there is no objectively best path forward. And I think the issue that you mentioned is a really good example. So it's not how do we communicate to different publics how to do this, but how do we have a broader societal debate that includes the best available science, but also all the other ethical, political, regulatory issues that, as I showed you, are very different in the US than they're elsewhere, and are very different elsewhere than they're in the US. So.
Okay, I have kind of a two-part question regarding anti-vaccination. So the first is that anti-vaxxers seem to exist on both sides of the political spectrum and across a very large ideological base. So I'm wondering if it is reasonable, or if we should even have the goal of having a single strategy of combating anti-vaccination. And the second part of that is, how do you have this kind of bidirectional dialogue where you acknowledge the lack of trust and the fear while still rejecting evidence from anti-vaxxers that is patently false, such as like vaccines cause autism? How do you kind of navigate that?
Yeah. And I'm going to throw in, before I answer, I'm going to throw in another complication, and that is vaccinations are also one of these really good examples, or the anti-vaccination movement is a really good example of a movement that actually weirdly uses science. So a lot of people say, well, it's totally anti-science. But the reason they continue to stick with Wakefield is because it's a study that was in a high-end medical journal, in a Lancet, right? And very often, and you see the same thing for the Serolini study for GMOs, the rat study and the tumor study, that the argument is, how did this get through peer review? How did this get into one of the top journals? And then why does it get pulled the moment it contradicts industry, what they perceive as industry benefits? And so people actually who are some people on the anti-vaccine side are making arguments that are deeply embedded in scientific reasoning. Now, the fact that this study has been retracted, that Wakefield lost his medical license, then becomes, collateral damage in that logical chain. But so for vaccines, and I think you're absolutely right that vaccines and vaccine hesitancy and or outright rejection is not independent, but happens on both ends of the political spectrum. I'll mention a few things. Number one, there's great work by Brandon Nyhan, who's done work in pediatrics, where he published, where he tried to basically do interventions and tell parents who were already reluctant. He had different groups, but the one group I'll talk about, parents who were reluctant to vaccinate their children, and he did a bunch of interventions, narrative interventions and so on. One of them is the straight CDC, this is why it's a bad idea intervention. When you then look at how likely they are to vaccinate their children after the intervention, the corrective group, meaning the one that got all the counter information, does more poorly than the control condition. Meaning if I hadn't talked to these people at all, they would be more likely to vaccinate their children than after I forced them to dig in and basically what he calls a backfire effect. I think there was a little bit of overclaiming on that paper, not by Brendan, by other people who read it. So it's probably not as widespread, always a phenomenon, but it's a really interesting kind of thing. What can happen if you talk top down? I, as a scientist, know what's right for you, kind of in the Paul Offit at Penn kind of way, and why that very often doesn't help, right? If I go to Jenny McCarthy, who thinks that her son Evan's autism is triggered, I think is what she calls it, by vaccines, then talking down to that person and basically telling, here's all the reasons why you're wrong, probably doesn't help. Number two is, I think we've done a pretty poor job, and this is where I'm going to borrow from a rhetorician. Kathleen Hall-Jamieson has talked about this, and she's convinced that the idea of herd immunity is a really bad label. And I'm not an expert on this, on rhetorics by any stretch, but the idea is, who wants to be part of a herd that goes over a cliff or does whatever else, right? Because everybody else does it, that's why I'm doing it. And so she's argued, and it's a bit of a more awkward term, but she's argued that maybe a term like community immunity or others may be better terms, meaning you're really doing something for the larger community rather than you being part of a herd. And so I think we haven't really thought about the complexities and how we communicate those things. And then I think number three, as I said, and this comes back to my first point, I do think that acknowledging the fact and not engaging in reasonable questions that people are asking. So this came up at a previous meeting. A person comes up to me and she says, well, you know, when I grew up, we only had this many vaccines. Now we have all these additional vaccines, and I want to know why that is. And our typical response is just doctors know better. And I think that's not a good way of communicating, right? Especially when it comes to decisions that parents make a lot of irrational decisions about their children. And I'm saying this with having no experience parenting, so I'm only on the receiving end of parenting. So, but I think, you know, people are helicopter parents. Is that a good decision? No. People, you know, don't let their children do X, Y, Z. Is that always a good decision? No. I'm sure most parents would admit that, you know, sometimes they're not the most rational choices, but they're choices that they're doing because they love their children. And that's the kind of environment that we're going into, and then we're saying, well, here's all the facts, and this is why you should behave differently. Ultimately, it all comes back to that knowledge deficit kind of model thinking that that model is typically used in science communication as a very outdated idea that if I just gave you the right facts, then you would think like a scientist. And we all know, of course, that that's not at all how things work. Most of us make most decisions based on very limited amounts of information. In political science and in psychology, we've called this the cognitive miser model for a long time. Yeah, by the time you got here, you've made at least, I don't know how many dozens and dozens and dozens of decisions about people that you've never met, if they're dangerous to you, if they may mug you, or if they may kill you, or whatever else. You didn't make any of those decisions consciously, but as you walk down the street, you look for all these cues and you make these decisions with absolutely no information whatsoever. Yet we all make them all the time. Why did I come in here today and wear this? There's no rational reason for this, right? There's no rational reason for anybody to ever wear a strip of cloth around their neck, and it's actually not that comfortable either, I can tell you. But I do it because one does it, right? So I mean, I constantly make basically decisions, and I think vaccinations are not any different. And so ultimately, how do I connect with a parent on the value that matters to them? And not in a corrective kind of, here's why I'm telling you why you're wrong. And I think a lot of the work that Brendan has been doing also with the Vermont Department of Health is really interesting in terms of working with people on the ground, trying to really figure out interventions that work on a day-to-day basis. He's at Michigan now. He did all that work when he was at Dartmouth. Mm-hmm.
So my question is related with the chart you showed us. That's very interesting. You pointed out two outliners there, US and China. Mm-hmm. So my question is twofold. One is related with communication discipline. The other is somehow related with political science or international relations. To what degree do you think the science communication issue is a US issue? Because you show most of the country, if the economic development reaches a certain point, there's no dispute on science communication, right? There's no trouble over there. People tend to be atheist. This is a US problem. So whenever we have an issue, we always say have climate change communication, science communication, health communication. And we see this kind of a proliferation of issue-based communication. And without addressing the core things, what's wrong with U.S. and how can we talk about saving the save the fire without talking the fire? I mean, it turns the communication into a kind of constant finance of the message into a sophistry. So I think this is enough it's not enough to solve the problem. The other thing is the two outliner. You see China and U.S. on the chart. Can you predict that the Chinese, like atheist communist regime, is more suitable for the future of technopoly, when they embrace the technology without any kind of resistance from religion or any kind of other things? You see, they are leading the 5G, they are leading the bullet train, they are leading even on WeChat and any other, social score and those kind of things, So this is a two-folded question.
All right, those are two really easy questions. What's wrong with the U.S. and do we need more atheism to promote science? So the first one, there's nothing wrong at all with the U.S., and I'll tell you based on data why that is, and I'll give you two things. One is, if you ask, and this has been done as part of the General Social Survey, if you actually ask the U.S. public, for example, on two questions, evolution and Big Bang, if evolution is the best way of describing how life develops on Earth, and if the Big Bang is the best explanation of how origins of the universe. If you ask this question in Japan, in China, in Europe, and they collapse the data for Europe, which makes little sense to put Lithuania in with Portugal and whatever else, but Europe, China, Japan, you basically get about 80% endorsement or more. In all of these countries. In the US, you get about 40. So, and to your point, is there something wrong? But that depends on how you ask the question. And what the GSS did, they basically did a split ballot, and they asked one half the standard evolution question, and the other half is, according to scientists, that's how life developed. Or for Big Bang, according to scientists. And all of a sudden, when you ask according to scientists, the number goes to 80% exactly where the rest of the world is. So what does that mean? That means that we know what we're supposed to know. We just refuse to know it, right? So we know exactly what the facts are. We just go like, yeah, but that still doesn't matter to me. So is there something wrong or not? I think at least factually there's nothing wrong. We know exactly what the facts are. They simply contradict our value system, and that's where our problem comes in. Is that a unique US problem? I'm not sure. So, and here's my counter argument. The National Academies of Sciences, Engineering, and Medicine about 3 years ago came out with a report that went through 1,600 peer-reviewed studies looking at the health effects. And the Pacific Northwest may not be the place to make this argument, but I'll make it anyway. That there's no piece of evidence that suggests that eating genetically modified crops is any less safe than eating traditionally grown crops. National Academies of Sciences, Engineering, and Medicine says, look, we went through every single study, there's no evidence. That doesn't stop Germany, you saw that at the very end, from rejecting GMOs outright, right? And basically saying, look, we don't believe the science. So rejecting scientific consensus on GMOs in Germany is not any different from rejecting scientific consensus on climate in the US. So is there something uniquely different about the US? I think there is in terms of religiosity. I think that's a value that's much more pronounced here than it is in most other developed countries. But that's just a function, or that's just a part of the infrastructure and the configuration, I think, that we need to take into account. And I don't think that necessarily produces unique problems. Climate in particular, I would push back. What we did for climate change, we took a 2000 election that worked out, by the way, exactly like the 2016 election, right? We have Al Gore running out of a Clinton White House, being predicted to win the electoral vote by about 70% of the vote. He loses the electoral vote. He wins the popular vote, reminiscent of 2016, loses his home state. Then Florida happens, right? And we need to do a bunch of recounts. We don't have time for recounts. Al Gore sues in front of the Florida Supreme Court, then sues in front of the US Supreme Court. Eventually, the US Supreme Court doesn't turn the election for Gore, but a few weeks in basically says, enough, we're stopping the recount now, wherever we are, we stop, and Bush 43 becomes president. The country has never been this divided. The Republicans walk around with signs that say Gore, sore loser men for Gore and Lieberman, right? And the Democrats to this day believe that the election was stolen from them by the Supreme Court. So what do? We take whatever that figure was who sued in front of both Supreme Courts, and we go like, that guy's from now on in charge of climate change. One of the most polarizing partisan figures. But that wasn't enough, right? So let's pile on. Let's give him an Oscar from the fundraising arm of the Democratic Party, Hollywood, for An Inconvenient Truth. Still not enough. Let's give him a Grammy for Best Audiobook for An Inconvenient Truth, because really we need to pile it on. And then, of course, the Nobel Committee, which is also not known for embracing conservative causes in the US, gives him a Peace Prize, and him and the IPCC. So ultimately, I think that is a bit of a self-made problem. The fact, and Bob Inglis, who is a congressman, Republican former congressman out of South Carolina, who lost re-election to a Tea Party candidate when he embraced climate change, speaks to this quite powerfully. It basically says, look, what happened is for any self-respecting Republican, this was the Democrats using science as a tool to get regulations through that they couldn't get through electorally. And I think this is what's so dangerous about the statements from a Neil deGrasse Tyson that are anti-religion, or that mock religion, or from a Michael Mann, that reinforce the idea that we're a bunch of liberals and partisans. The scientific community is, because we're really feeding that misperception. So to your second question about religion, I mean, I think it's an interesting question. I think Germany, which ends up a little bit higher on this, is I think a counterexample of a country where I grew up in West Germany, the South, highly developed, lots of investment in science. It's actually fairly religious. The reason why Germany dipped is because after the reunification, they added 20 million people who had lived under communist rule for a long time, and basically levels of religiosity just plummeted because you put a bunch of zeros in the mean and your mean goes out. And that's what ended up happening. So I think Germany is a good counterexample where, you know, that's not necessarily, the two are not necessarily at odds with one another. I think the US for a long time was a good counterexample. I think what the US right now where the US is that the US is often rallied around crucial events. The Manhattan Project being a really good example, meaning scientists urging the president, look, there's Carl Friedrich von Weizsäcker is creating the nuclear bomb. We need the Manhattan Project. The fact that a few years later they wrote another letter saying, please don't apply the technology we urge you to create is a different question. Sputnik moments and so on. And I spoke recently to a member of the House Science Committee, a Republican member of the House Science, a staffer of the House Science Committee, and his answer was just to come back to China. What he was saying is what we need in the US is we need the Chinese to go to the moon and land a person on the moon, and on the way back pick up that flag that we still have up there, that American flag, fold it up and stop by the White House and drop it off. And all of a sudden, we're going to have the biggest investment in science and technology in the US. And there may be some truth to that. I don't know if that's going to happen anytime soon, but I think we've been very responsive around some of the international kind of comparison issues. The last thing I'll mention is, and I think we need to wrap up, there's a very interesting story around a guy named Ed Yu, Y-O-U, who's a special agent for the FBI, and he's really interested in basically theft of DNA data and building the largest databases. And the Chinese, apparently most of the thefts of US patient data that have occurred were not about patient data or financial data, but about getting actually their DNA data to build the largest possible DNA data set, because of course the Chinese are also getting to the point where they're sequencing the DNA of all newborn babies. That would give them an unbelievable competitive advantage, religion or not. And already the Chinese are out publishing us in scientific journals on most issues. Nano was one of the first ones. So I think the question that you're raising is going to be an interesting one and a continuing one moving forward. I don't have a good answer, really.
So I know that there are more questions. We have a reception in the next room just down the hall, so in CMU 126. So please join us, and please join me in thanking Dietram
Thank you so
once
much.
again.